Okay, well today I'm going to bring us back to our backyard and just go over some of the research I've been doing with Chris Johnson and Dale Sipe over the last few months, really trying to better quantify landscape change in the Peace region. So I'll begin by just introducing you to some research goals and objectives. We'll talk just briefly about the Central Mountain DU, as we've kind of had an introduction to that already, and learn a little bit more about the Peace study area. And then we'll discuss how resource selection functions were used to kind of assess caribou habitat. And then in order to look at the response of caribou to industrial developments, we looked at the zone of influence. And then in order to quantify landscape change, I'll kind of discuss those methods as well. And finish with a brief summary and management implications section. So really this project was initiated to quantify levels of landscape change and therefore habitat loss, in addition to better understanding caribou distribution and their response to large-scale industrial developments. Within the context of our research goal, we investigated caribou distribution, caribou response to current levels of industrial developments, and natural development, or natural disturbances, which could also include fire. And finally, to then quantify landscape change over time for 6 study herds. So why caribou? Well, as we've learned over the past couple of days, the abundance and distribution of woodland caribou has decreased across North America since the colonization of humans. Currently, as we have learned from other individuals, caribou in this area are now considered part of the designatable unit, the Central Mountain caribou. And they are currently listed as threatened under the Species at Risk Act. This reassessment acknowledges that these caribou of this designatable unit, which is 8, are behaviorally unique. They demonstrate different wintering strategies between some individuals and then within their populations as well. They're generally secluded from other designatable units, mainly by topography, so they're mountain ranges and also large reservoirs. And thirdly, they're genetically dissimilar in that they, with the mixed lineages from their neighboring populations, the Northern Mountain, Southern Mountain, and then the boreal populations to the east. Furthermore, the caribou populations of the Central Mountains are semi-unique in that they are also exposed to not only a couple of types, but a large variety of industrial developments that threaten the integrity of their habitats. Since the early 1990s, regions around the Peace River have experienced rapid land use change from resource extraction activities. These are associated with large-scale forestry, mineral, and energy, in addition to agricultural development. The cumulative effects of those industrial activities have resulted in a progressively younger and more fragmented landscape. So welcome to the Peace study area. It is quite large. From where we are today in Fort St. John, we're going to move into the Rocky Mountains, and we'll start from the northwest to the southeast. This entire area is roughly around 41,000 square kilometers, and we have some topographic and geographical features that kind of separate some of these herd boundaries. So in the northwest, we have the Graham herd, and this herd is actually in the Northern Mountain designatable unit, but it's included in this analysis. We have Moberly just south of the Wilson, the Peace Arm reach of the Wilson Reservoir. Burnt Pine, which we've heard a lot about with the extremely low population. Quintet is just to the southwest of Tumbler Ridge. And then we go into the lower elevation habitats and to some of the boreal forests, and we see the bare-hole red willow and the narrow-way herd in red. And this opportunity also gives us a really good idea of how to better understand how these disturbances are impacting caribou, again, with these different wintering strategies. So we have some of the individuals in the lower elevations, and we're comparing that with some of the individuals that winter in the high alpine habitats. To address our primary research goal, we first developed resource selection functions to determine the seasonal habitat selection for caribou, demonstrating these different wintering strategies. We did this for both the current 2012 landscape, in addition to a proposed pre-disturbance landscape, which I then called the 1990 landscape. And just important to consider, the 1990, there were disturbances that go back to the 50s and 60s, there were fire, and there were some wells from the 60s, and those are included in this analysis. But the majority of the boom of oil and gas I guess forestry came around the 70s, but kind of the oil and gas impact started around 1990. I also looked at the seasonal responses of caribou to individual disturbance types by measuring the zone of influence for each disturbance type on the landscape. And finally, I assessed landscape change over time. So what is a resource selection function? A resource selection function is any mathematical equation that actually produces a coefficient that will represent the selection for or the avoidance of a specific habitat or disturbance feature in the environment. These resource selection functions allowed us to relate where caribou spend time based on their GPS color locations to a number of variables that I really hypothesized would influence their distribution. I hypothesized that forest cover, topography, the distance to disturbance features, and also the density of disturbance features would influence the distribution of caribou. And then what's really neat about these resource selection functions is that these coefficients can then be used to develop maps. And these maps can become very powerful management tools. And I use the resource selection models to then identify kind of 4 main classes of habitat. And those are also classified based on the actual use locations of caribou and their GPS colors. Now we can see pretty easily that the warm areas in red and orange represent very high and high caribou use areas, or the relative probability that we would expect to see caribou in those areas. And then there's also a moderate class and a low quality habitat class as well. To determine or understand how caribou respond to disturbance features, I looked at both kind of a natural disturbance, fire, and then of course the industrial disturbances. And I used methods following Belanger et al. In 2009 to determine a zone of influence for each feature type. And this is just an example, so it would run a lot of iterations of this mathematical equation. And I would look at the log likelihood that was produced, and we could see that if I did this and used a different distance for each of those models, I could look at where the avoidance behavior occurred relative to that log likelihood. And where it asymptotes up at about 3,000 meters is what we would consider the point that caribou are responding to this disturbance type, and the response for this being an avoidance response. So we could say that for the quintet herd in summer, they were avoiding coal mines up to 3 kilometers. And lastly, to quantify landscape change over time, what I could do is take the map that I developed for the 1990 pre-disturbance era and subtract the 2012 map from that. And that would result in a % of landscape change for each of these 4 habitat classes. So with the resource selection functions, we produced 24 seasonal habitat models, which then transmitted into these maps. And so for each caribou herd, they have a summer and winter 1990 pre-disturbance map, and then a summer 2012 and winter 2012 current landscape map. So to spend a little bit of time on the zone of influence, I did this for each feature type, and we can see the feature type is on the left-hand side, and then each of the herds across the study area represented at the top of the table, and then there's a section for summer and winter seasonal range. And we're just going to focus kind of on the average today. And so we can see that caribou avoided roads out to an average distance of about 1.4 kilometers. Caribou also avoided seismic and pipelines up to about 1.67 kilometers. And I have this asterisk because for the narrowway in the boreal forest, there were multiple asymptotes that I just had to kind of interpret these results a little bit differently for. And so I actually, just for the purpose of averaging, removed that from the average. For cut blocks less than 30 years of age, caribou were avoiding them out to about 1.75 kilometers. For nonlinear disturbances, which included oil and well pads, we saw a caribou avoidance response up to 3.4 kilometers. For coal mines, really Quintet was the only herd that contributed to this, but they avoided the coal mine out to about 3 kilometers during the summer season. And finally, for fires, we see avoidance response out to over 5 kilometers across some of the mountainous and boreal habitats. So finally, and to look at the landscape change, I'm going to run you through just the 4 classes of habitats for each season. So in red, we're looking at the highest quality of caribou habitat in these maps, and we can see that for all herds, we see a reduction in this very high quality habitat across the range, with the highest being in the boreal herd group at about 47%. Now notice in winter, those numbers change, and we see a pretty big increase in a loss in almost 66% for the boreal herd group in that very high quality habitat. So for high quality habitat, we also see a reduction in the majority, but we see a little bit of an increase in that range in a couple of the herds during summer. Looking at winter, we see that the narrowway experienced the highest loss of the high quality habitat class at about 53%. For moderate quality, again, we see some lower numbers, and we see an increase in boreal habitat at about 10% and a reduction in under 20% for other herds. And in winter, even these moderate classes we're seeing a pretty large reduction across the lower elevation boreal forests, and up to roughly almost half of their even moderate quality habitat being reduced or changed. And I always think it's interesting to put the low quality classes, because this is kind of what's remaining on the landscape. And as we expected, you see an increase in some of these low quality habitats. And in winter, another variety of even up to 38% of an increase in these low quality habitats. So in summary, maps developed from these resource selection function modeling techniques can produce coefficients that we can generate maps from that can serve to be a pretty powerful management tool. Values generated from the zone of influence analysis seem to parallel past studies, and also might be a tool that we can use to help guide some management decisions. What we observed was that core winter range seemed to experience the greatest levels of landscape change. For herds that were in the boreal forest, they also seemed to experience the greatest loss of habitat, up to 66% of the very high classified habitat and over 50% of their high quality habitat that was really lost and changed to different values during winter. And finally, for herds wintering in the higher elevation habitats, it seemed that the Moberly and burnt pine area had lost up to about 40% of their very high quality habitats during the winter season. So I'd like to thank the Habitat Conservation Trust Fund and UNBC and NSERC for providing funding for this study. And then Chris Johnson and Dale Sipe provided an enormous amount of research and analytical support. And then also some personal support as well. So thank you very much.